Hey you guys! What's up my fellow math goonies? In this video we're going to be talking about terminology to talk about the sizes of a matrix. We've talked a lot about the relationships between scalars, vectors, and matrices. Specifically, we've seen that all scalars are vectors, all vectors are matrices, but the reverse is not true. There are vectors that are not scalars, just like there are matrices that are not vectors. Sometimes when talking about these different data structures, it's really powerful to be able to distinguish between those three categories of data. And that's the exact terminology we're going to cover in this video. Let's start with the easiest case first. A scalar will always refer to a one-by-one matrix. Anytime we use the word scalar, we know immediately that there is just one row and one column, and then the entry of that scalar is filled appropriately. Anytime we refer to a row vector, we say that that is a 1 by n vector where the number of columns n might be bigger than or equal to 1. If it's exactly equal to 1, that's called a scalar, but it's also called a row vector. Sometimes we want to be able to say, this is a row vector that's definitely not a scalar. And you know mathematicians, the lazy bums, they don't want to use all the words, so what they'll say is, well, that is a non-scalar row vector. And what that means is n's got to be greater than 1. In other words, the number of columns is bigger than 1. That row vector is not a scalar, non-scalar row vector. Could you guess what the analogy is in column vectors? I know you can because you're hella smart because you work hella hard. Column vectors are vectors with m rows and 1 column where m might be bigger than or equal to 1. When we say non-scalar column vectors, we mean that m is strictly bigger than 1. So it's a column vector that's not a scalar. That leads us to one of the major lessons of today, which are mathematicians are lazy bums. Sometimes they don't want to get so precise, so they'll just say vector, and what they mean is either a column vector or a row vector. In other words, one of the dimensions has to be 1 in a vector. The other one could be non-1. When we say a non-scalar vector, we mean either a column vector or a row vector where one of the dimensions is definitely not equal to 1 and the other one is definitely equal to 1. So a non-scalar vector is a vector that is definitely not a scalar. That could either be a row vector or a column vector. We're leaving it open to interpretation. Remember, laziness sometimes causes pain, which is in this case ambiguity. The last data structure that we're going to talk about is a matrix. A matrix is an m by n data structure where the number of rows and the number of columns can be bigger than or equal to 1. A 1 by 1 matrix is known as a scalar. Indeed, that satisfies the definition of a matrix. When we say a piece of data is a non-scalar matrix, we mean it either is a non-scalar vector or it's a non-vector matrix. What the hell did I just say? When we say something is a non-scalar matrix, all we're saying is it's definitely not a scalar. It could be a row vector, it could be a column vector, or it could be a larger matrix. We don't care. We're just saying for sure that matrix is not a scalar. On the other hand, if we say something is a non-vector matrix, we know for sure that it is an m by n data structure where both m and n are greater than 1. It's definitely not a row vector. It's definitely not a column vector. It's no type of vector. It's got to be a matrix. Those definitions allow us to distinguish quite clearly whether or not we want just a scalar, just a non-scalar vector, or just a non-vector matrix, or if we want some combination in between. We'll use these throughout our videos to be quite clear. This is an introduction to those thoughts. The community challenge of today is, can you come up with a diagram that accurately describes that? I'll tell you that it took me about an hour of thinking to come up with a useful diagram, and I'm not going to show that to you because that's the challenge for today. Thank you so much for your attention. I love hearing your comments and questions in the link below. I'm going to start trying to break things up and be more myself. I'm still learning how to become a video content creator, and I'm kind of tight in those old ones. I kind of want to slap myself around and say, loosen up, brother. All right, I'll see you in the next video. Peace.